Welcome back to the deep dive. So today we're doing something a little different. We are stepping away from the mouse. We're leaving behind, the comfort of the desktop, the icons, and we're staring into that black screen.
The abyss, the blinking cursor.
Exactly.
And I mean, for most people, that screen usually means something has gone terribly, terribly wrong.
Right. But for the material we're covering today, which is from the CompTIA A+ modules on Linux and macOS, that black screen is where the real power is.
It's where the work happens, yeah.
It feels like that's where the user stops and the admin begins.
Yeah.
So our mission today is really to demystify that whole experience.
And hopefully convince you that you don't have to be afraid of it.
And try not to accidentally delete the entire operating system while we're learning.
Which is surprisingly easy to do if you're not careful.
Yeah.
But that's the trade-off, right? You give up the safety rails for just raw power.
Okay, so let's start with the basics. The environment. The source material talks a lot about shells. Now, to me, a shell sounds like, the outer casing.
That's a good way to think about it, but it's maybe more like
Right.
a negotiator.
A negotiator.
Yeah, or a translator. Think of it this way. The core of the OS, the kernel, it speaks directly to the hardware. It's speaking, ones and zeros,
Okay.
and you speak English or at least text commands. The shell is the thing that sits in the middle and translates between you and the kernel.
So when I open that terminal window, I'm not actually talking to the computer. I'm talking to my translator.
You're talking to the shell. Exactly.
Yeah.
And the sources make a really important distinction here between an interactive and a non-interactive shell.
Interactive seems pretty straightforward. That's the conversation, right? I type something, it answers back.
It's a live chat. But the non-interactive shell, that's where all the automation happens.
So that's like a script.
Exactly. Imagine you just write a list of commands on a piece of paper, hand it to the shell, and walk away. It just runs through them without you. That's how servers update themselves in the middle of the night.
It's the set it and forget it robot.
Perfect analogy. Now, you'll also see different flavors of these shells mentioned, like Bash and Zish.
Are they just different brands of the same thing?
Pretty much. Bash is the classic. It's been the default forever. Zish, or a Z shell, is the newer, slightly fancier version. It's the default on Macs now.
Okay, so we've got our translator now. Where are we? In Windows, I'm always looking for my C drive. But the docs here say, in all caps, there is no C drive.
And that is probably the single biggest mental hurdle for anyone coming from Windows.
It feels wrong.
It does, but it's just a different philosophy. Windows organizes things by physical drives. C is one hard drive, D is another. Linux uses what's called a unified directory tree.
The tree, right.
Everything, and I mean everything, starts from a single point called the root, just a /
Just root.
Yep. Every file, every program, every USB stick you plug in is just a branch on that single tree.
Okay, but what happens when I plug in that USB stick? Windows gives me a pop-up, new E drive. Linux just sits there.
It sees it, but it doesn't assign it a letter. You have to tell it where to go. You have to mount it.
Mount it.
You basically pick an empty folder anywhere on the tree and say, hey, that USB stick, I want its contents to appear inside this folder.
That seems really manual.
It is, but it's incredibly flexible. And there's a file, etc., stab, that's basically the map. It tells the system what to mount automatically when it boots up.
So that's the seating chart for all your storage. Okay,
Yeah.
I think I'm with you. Now let's move around in this tree. I see PWD for where am I, and CD for change directory.
Right.
But typing out home user documents projects deep dive every time seems awful.
It is awful. Nobody does that. You use shortcuts. The two you absolutely have to know are the double dot and the tilde.
Exactly.
Exactly. CD moves you up one level. It's your back button. And CD, the tilde, is your get me home button. No matter how deep you are, it teleports you right back to your personal home folder.
That feels like something you'd get into muscle memory pretty fast.
Oh, you do?
Okay, file management. We've got Ls to list files, CP to copy, but then there's MV for move, which seems to be doing double duty.
It is. It moves a file, but it's also how you rename a file.
Which always felt weird to me. Why isn't there just a rename command?
Well, think about what's happening. If you move a file called report.txt to the same folder, but you call it findraport.txt,
yeah.
have you really moved the data?
No, I guess not.
You've just changed its name, its path. To Linux, it's the same logical operation. It's just really efficient.
Speaking of efficient,
Yeah.
we need to talk about the command that causes the most stress, .rm.
The remove command.
Yeah.
Yes. And let's put this in bright, flashing neon lights.
Go for it.
In the Linux command line, There is no recycle bin. There is no trash.
When you delete something, it is gone.
Vaporized. It's like the Shift+Delete key in Windows, but it's the default. The system just unlinks the file and marks the space as free.
So if I accidentally type ARM my entire thesis...
You'd better have a very, very recent backup.
That seems so unforgiving.
It is. But you can give yourself a little safety net. Use the II flag.
I for interactive.
Exactly. If you type ARM-NI file name, it will stop and ask you, are you sure? And you have to physically type Y to confirm.
That seems like it should be the default.
You'd think so, but the philosophy of Linux is that it trusts the user. It assumes if you typed it, you meant it.
Okay, let's move on to finding things. If I can't see the file, how do I find it?
Two main tools. Find is for searching for file names. Pretty straightforward. But the real superpower is grep.
Grep? What a strange name.
It's an old acronym. Don't worry about it. What it does is search for text inside of files.
Oh, like Kitterol plus F for your entire system.
Exactly. But on a massive scale. You can tell it, search through these 1,000 log files and show me every single line that contains the word error.
That is a game changer.
It is. And it gets even more powerful when you combine it with the pipe. That's the vertical bore symbol.
The sources call this piping. It seems like a core idea.
It is the core idea. The whole philosophy is to have lots of small, simple tools that do one thing well. The pipe lets you chain them together.
Okay, give me a practical example.
Sure. Let's say you want to see if Firefox is running. You could type pips to list every process. But on a busy server, that could be hundreds of lines flying past your screen.
Totally unreadable. Useless.
Right. So instead you pipe it. You type p o grep Firefox.
So you take the huge list from IPS and you feed it into grep.
And grep acts like a filter. It catches only the lines with the word Firefox and throws everything else away. You get one clean, simple answer.
It's like an assembly line for your data.
That's a perfect way to put it.
Okay, let's talk security. The permissions. I'm seeing these numbers everywhere in the docs. 777, 755. It looks like code from the Matrix.
It looks scary, but it's actually just simple addition. You only have to remember 3 numbers.
They on me.
4 is read, 2 is write, 1 is execute.
4, 2, 1. Okay.
Yeah, and you just add them up for what you want. So if you want to be able to read, write, and execute a file.
I do. 4 plus 2 plus 1.
Yeah,
that's a 7.
You got it. That's a 7. And every file has 3 of these numbers. 1 for you, the owner, 1 for your team, the group, and 1 for everyone else.
Let's try one. 755. What does that mean?
Okay, so the first number is for you. That's a 7. Full control.
Right. Read, write, execute.
The next 2 numbers are 5. So what's 5?
4 plus 1. So read and execute, but no write.
Exactly. 755 means you have full control, but your group and everyone else can only read and run the file. They can't change it. It's a very common setting for web servers.
And 777
is the don't ever do this setting. It means anyone and everyone can do anything to that file. It's like leaving your front door wide open with a sign that says free stuff.
Got it. Okay, installing software. This is way different from Windows, where I'm used to downloading a .exe file.
Yeah, Linux kind of pioneered the App Store model decades ago with package managers. You'll see apt on Ubuntu or DNF on Fedora.
And you don't hunt for downloads on the web?
Nope. You just tell the package manager, apt install Firefox. It goes to a trusted library, a repository, finds the official version, and installs it. Even grabs any other little files it needs to run, the dependencies.
It handles the dependencies. That's amazing. No more DLL not found errors.
Exactly. It's just cleaner and way, way more secure.
But to do that, you need to be the admin, right? You need to be root.
You do. But here's the paradox. You need root power, but you should almost never log in as the root user.
Explain that.
Logging in as root is God mode. There are no safety nets. You could delete a critical system file by accident, and the OS won't even ask you twice. So we use sudo.
Super user do.
Right. It lets you borrow the root powers for just one single command. You type sudo apt install Firefox. It asks for your password to make sure it's you, and then it runs just that one command as root. Then the power is gone.
It's like temporary admin privileges.
It's the single most important safety feature. It forces you to be mindful of when you're making a big change.
Okay, quick fire round on networking tools. We've got ping.
The basics. Are you there? Checks for a connection.
Traceroute.
Shows you the exact path your data is taking across the internet, router by router.
Dead.
Asks the internet's phone book, the DNS, what's the IP address for this website?
And finally, automation. The cron job.
The heartbeat of any server. It's just a scheduler. You tell it a time, a date, and a command, and it will run it.
But the syntax is those 5 stars.
It looks weird, but it's just a sequence. Minute, hour, day of the month, month and day of the week. Once you learn it, you can set a backup to run every Monday at 2 a.m. and just forget about it.
So before we wrap, let's touch on macOS. People see it as this super user-friendly thing, but underneath.
Underneath, it's a Unix-based system. It's a cousin to Linux.
So all these commands we just talked about.
Yeah.
Cls, grep, chmod.
They all work
Yeah.
perfectly. If you open the terminal app on a Mac, you're dropped right into a Z shell, just like we talked about.
Right.
You're basically a macOS power user if you know Linux.
So to bring this all together, what's the big takeaway? We've gone from file navigation to permission math.
I think the key thing is that the command line isn't something to fear. It's just the direct path. The graphical interface, the windows and icons, that's a simplified layer on top of it.
It's an abstraction.
Right. Learning the command line is just taking that wrapper off and speaking directly to the OS. It's faster and more powerful. And yeah, a little more dangerous, but that's what control is.
I want to leave our listeners with a final thought, pulling from that permissions segment. We talked about read, write, execute.
4, 2, and 1.
Think about the apps on your phone right now. When you installed them, how many did you just blindly grant full read, write, and execute permissions to?
We all just click allow on everything.
Right. You give them 777 access to your photos, your contacts, your microphone, without even thinking about the chmod command you just implicitly ran.
That's a really good point.
You are the system administrator of your own digital life. It might be worth taking a minute to go check your permissions.
Absolutely.
Thanks for listening to The Deep Dive. We'll catch you on the next one.